Going inside the world of ecological chemistry of pest control and asking a simple question but powerful question. Can smarter materials help us move away from the harmful pesticides while keeping food systems productive and resilient?
It takes almost 12 years and $300 million to bring a single new
Single
active
product?
ingredient to the market.
Wow.
Just the commercial material claims to work for 90 days. We came back after 200 days to the traps and sent the samples to a lab to test how much this compound, this methyl-eugenol, left inside the materials. They started at 30%, the commercial dropped to 5%. We started at 20%, dropped to 10. The 10% we started dropped to 5.
In a span of
200
200
days.
days.
200 days in the Israeli summer.
You had to design a 10-year roadmap for India to reduce its reliance on harmful pesticides while keeping yields and farmer income stable. What pillars would you include? Would it be materials innovation? Would it be IPM adoption? Or is it policies, incentives, data? What according to you?
Well,
Hello and welcome to the Carbon Circle. In this episode of the Carbon Circle, we are going inside the world of ecological chemistry of pest control and asking a simple question but powerful question. Can smarter materials help us move away from the harmful pesticides while keeping food systems productive and resilient? My guest today is Gilad, the CEO and co-founder of Platypus, an Israeli materials innovation startup that has developed PlatyForm, a slow-release gel-based delivery system that helps natural actives like essential oils and pheromones last for longer in real world conditions. Gilad grew up in a family of dealing with chemicals and materials business, working his way from forklift driver to R&D manager before bootstrapping Platypus with a mission to make pest control more sustainable, practical, and scalable. Gilad and his team have already won global recognition for innovation in biocontrol and are increasingly visible across agri-tech conferences and food systems innovation forums. Gilad, welcome to the Carbon Circle.
hello, happy to be here.
Pleasure to have you, Gilad. So, for our listeners, business leaders, sustainability professionals, and decision makers, our conversation today will follow 4 arcs. The first is your industrialist turned ecological chemist journey. We'll look at Gilad's journey. The second topic or the subtopic is the problem space, why synthetic and biological pest control solutions are stuck in an expensive, slow, and often unsustainable innovation cycle. The third subtopic is Platypus' solution and business model, how single materials platform can shift the economics of pest control. The last subtopic is the India 2047 vision, what Israel and India collaboration around sustainable pest control could look like in practice. So let us start with the human story behind the science. You have described yourself as coming from a very industrial, materials-driven background, growing up inside a family company in chemicals and materials, doing everything from manual work to running R&D. At the same time, Platypus today sits at the intersection of material science, design, agriculture, and sustainability. I would love for you to unpack that journey for me, Gilad. So, walk us through your childhood and the early career in the family chemical business. What did the factory floor teach you that later shaped on how you think about innovation and sustainability?
Well, I'll try to make it short. Well, the company I grew up in is a company that my grandfather started it around 1938, almost 90 years ago, still operating until today. And it's a company in in contact adhesives, basically. Over the years, my father and uncle took over, and I'm as a child, I went with my father to work in vacations, in school vacations, and I started, basic stuff, working being with the people and working um, with the workers at the production floor. Um, and eventually I started to actually have some positions for a month or two when I had the time. And there I learned um, to admire the people that work there. Usually hard workers, but I learned to see how creative they are and how professional they can be for doing simple tasks. How they improve what they are doing, the hard work, how simple changes makes it much easier doing this work because it also includes physical work.
Mhm.
Uh, Later on, the company changed and developed new product lines and new brands in the bicycle industry and other sectors. The company called the Adestic. Um, and then I progressed inside the company with the company, became the production manager and worked in the R&D department, and then moved to the marketing, product design. And during this time, I also finished my bachelor degree in
Mhm.
in polymer science and polymer engineering, and my master in product design. Uh, so it helped me to see different aspects of of a company, of an industrial company,
Mhm.
and how it works and operates. And I learned how one small change in the process could help other people. If I'm fixing something in a company in the company in one department, and just the way you do it a bit differently, it helps other departments as well. And this way you can save a lot of raw materials. Or you have a way to think that um, if I'm taking a material that, let's say, is not in good quality, that it is a defect. Someone spilled one of the materials in double dosage
Mhm.
inside of and you can't send it to the customer. But if you make some changes, you can fix it and you saved money instead of
Sure.
throwing it away. And from the sustainable point of view, you
Yeah,
saved a lot of raw materials.
absolutely. But Gilad, if I were to ask you, if you were to compare your education versus your time spent on the shop floor, which has taught you more when it comes to business building?
Oh, I think education, the academic education, gives you some tools, but it doesn't give you experience.
Mm.
When you're building a business, you can do it without experience. Most likely, you'll make more mistakes along the way. And this is the most vulnerable time of a business when it is at the beginning. Doing
Mhm.
mistakes is it could be fatal. Working at a company at the production floor, you get to see to you get experience
Right.
and you learn how to avoid it and how to improve it and how mm, later on when you meet a customer, how to you have a common language
Right.
with them, and you know what are the pain points and how to fix them.
Mhm.
So I think you need both of them when you're running a business. But
Sure.
you can do either of these without experience or education. We have a lot of examples in the history, so
Right.
I guess it's more individual.
Yeah, the reason I asked you this question is when I was going through one of your LinkedIn posts where you have spoken about your father. You mentioned that he had no formal education, but he could sense things do aspects that are very, engineering focused, right? So would you want to share some thoughts on that?
Oh yeah, well it's hard to believe, but you got to, but once you see it, you believe it. Um, he used to have this really without any formal education. My father was a great chemist, and he
Hmm.
never knew chemistry at all. He had a lot of experience. He could break down a formulation just by touching it, a competitor's formulation just by touching
Hmm.
it, smelling it, and play with it a little bit. And then without analytical tools, it could understand what's the formulation and break down exactly all the ingredients inside. Um, I've seen him doing it many times, and it's not
Fascinating.
just as a trick. Yeah, not as a trick, not as a party
Yeah.
trick, but just as experience because he didn't knew and didn't have a formal education. He used his senses to understand what he sees and what every material he adds change the last the result of the material.
Sure. I mean, it's quite fascinating to learn that, and it also talks volumes about the kind of experience that adds to business building, and the kind of experiences that you have exposed to, maybe two generations of, when you're being exposed to that, your grandfather starting it, and then your father taking it over, and now you seeing it through. There is definitely a lot of learning, and on top of that, you had your own bachelor degrees and the masters in product design. Brings and I think makes you the right fit for the firm that you're today building, Platypus. So we'll definitely dive deep into what Platypus does and the kind of work that you're doing. Let me ask you this, Gilad. So, at what point did you start to feel that the traditional pest control and chemical approaches were misaligned with where the world and the agriculture needed to go? Was there a specific moment or a project that triggered the platypus idea?
Um, well, this understanding that the industry needs to do things differently came to understand when we understood that what we need to do to get to the market, basically.
Hmm.
Um, at the beginning, we just wanted to develop a product for agriculture from A to Z.
Hmm.
Um, and still, we understood very fast that we don't know how to work with a farmer. I know how to
Hmm.
work with the materials and in a factory and B2B, but I didn't know how to B2C or with the farmer basically. Um, and the process is very long and complicated to register a product in this sector in the pest control industry,
Hmm.
and it costs a lot of money also. So basically, we pivoted and offered our formulation technology instead of developing a product.
Hmm.
And we wanted to just give our formulation, we'll go probably deeper into what our solution is,
Hmm.
um, but to offer it as a platform to
Hmm.
other companies and basically be to be B2B. So this
Right.
way we turn to companies we first saw as potential competitors into potential customers. That's the big shift that we've done. And the best part was that we are the only ones offering something that works this way, basically. So we know it is the right thing to do from the feedback we get from our customers. It makes them sense for them, and they feel the advantage it brings them,
Right. But
basically.
today, do you deal directly with farmers in that case, or do you work with other businesses trying to provide them with your formulations? How does it work?
So most of our work is with companies,
Hmm.
because if we're working with a farmer, uh, he needs someone to later on develop the solution, the product itself, and make it
Hmm.
to register it, to distribute it. Most cases, they can't really buy it directly from us because we are not giving them the solution. We are the platform for the solution.
Right.
So they need someone in the middle. But we work in the farmer in a way that, okay, now once we understand what's it's going to be and what they need, and we see it works, now we can go to a company together, tell them, here is a product, here are the results. You can just manufacture it.
Hmm.
You already have a customer. So it gives some benefit to work with the farmer, but we are not doing it. We know we are not perfect at doing it because
Hmm.
we need to focus on developing the product.
Right.
And we know we don't know how to develop a good product.
Right.
We think other companies can do it much better and they could be our customers. So that's why
Right.
we're trying to avoid it, but we're still doing it from time to time.
Sure. So you're leveraging on your strong points rather than working on building fresh teams to work on engaging with farmers directly. So let me try and understand this, Gilad. You have a product design background, so understanding the voice of consumers or rather customers is significant, right? So when you're trying to come up with this formulation, which could be an alternate to the regular available chemicals out there in the market, which is named as pesticides, for example. How did you try and get those voices? I mean, did you try and reach out to the farmers, or did you have a list of pain points that is already provided to you? How did this entire the product design thing work out with Platypus?
So the product design is got a few stages. First of all, we are connected to the industry and
Mm-hmm.
we know companies and we understand the pain points for each position in the company.
Mm.
I'll give you an example. The R&D guy or girl that they are working at the lab, they need to develop a formulation at the pesticide. Now, the pesticide, let's give a bit of a background. What is a pesticide?
Right.
It contains two parts. It got the active ingredient,
Mm-hmm.
the material that actually interacting with the pest,
Mm-hmm.
and there is the rest of the material of the in the product, which it calls in a carrier or delivery system, because it's called a system because it's several different product materials
Mm-hmm.
building together a system, a chemical system, to help deliver the active ingredient from the factory to the point in the field that it need to be released and meet the pest. And it usually just an inert material. So it doesn't really changing the way the active ingredient work in the field.
Mm-hmm.
So when we're looking at a company that need to develop a pesticide, they need to develop a delivery system for each product.
Right.
So a company with 100 products would have 100 delivery systems. When we're coming to the company, telling them, do you want more new products? They'll say yes. So, but how fast can you do it? Well, they'll tell you one product a year, maybe two. Best companies can do 5 new products a year.
Mm-hmm.
These are the numbers. And we're telling them, well, with our platform, you can do 5, 6, 10 new products. It's up to you. You can do it
Okay.
much faster, much easily, and you'll get a very good technology in the field with it. So we save a lot of time to the R&D team. Then we're going to the regulation team. and they are the ones that need to register the product.
Mm-hmm.
And we're telling them all the ingredients here are natural source. So they'll say, great, the process to register this product would be faster. Then we're
Right.
going to the operation and tell them instead of buying 10 different 10 different raw materials, you have one.
Mm-hmm.
So in storage, it's easier, production is easier. Then you're coming to the marketing and telling them you're going to have new products that
Mm-hmm.
would be easier to sell and more products every year. So they're happy as well. So the idea is to design the product in a way that benefit the company and prevent from people to say, no, I don't want it.
Right.
They'll see the benefit in it. So the design is not only always a design as how a product looks, but
Mm-hmm.
also as how you present it and what's the service you're giving them.
Sure, sure. I mean, the sort of explanation that you gave to what a pesticide is. Can you dive a little deeper for so that our listeners can understand how a pesticide is manufactured? What do you mean by an active substance, an inactive thing, and what do you mean by a delivery of it? Can you go into those details?
Yes, well, first of all, we have all of us know some good examples for similar chemistry, let's say this way, but
Mm-hmm.
in different field. Medications, we know it because you're buying a headache pill, and then you have a very small amount of active ingredient. Usually they write 1% or 0.1% of something.
Mm-hmm.
This is the active ingredient, but the rest is the delivery system. So, um, for example, of um, of what we'll see maybe in the store.
Mm-hmm.
Um, these kind of gel baits for ants or cockroaches. These are similar in a way. They have some
Okay.
kind of poison inside, but
Mm-hmm.
it's not all poison. The
Right.
poison is a very small dosage,
Mm-hmm.
but the rest of this kind of gel as bait is basically sugar.
Mm-hmm.
So the insect come and eat it, the ant eat it, swallow with it the active ingredient, but it doesn't work very fast.
Right.
It will work only when it go back to the nest and then it infect other ants. So that's the idea in many cases with pesticides. You either spray it, you put it in the water of the plant or inside the soil or around the field, and it interacts with the pest. It can attract it into traps. It can attract the predators of the pest, and it can also exterminate the pest in different stages of its life. And it could be from beetles to worms to flies and many other types of insects, rodents, uh, bacteria, fungi, and many different animals.
Sure. So let me try and understand where is the problem area within this, because when we say there is a delivery system which makes up to the majority of the entire component part, and then there is the poison itself or the active substance that kind of uh, makes or kills the pest that is to be addressed, right? So when I was trying to read up the work that you're doing, there is a specific area that you're trying to focus on, which is the the amount of time it can last and the how it delivers. Maybe that's the part that you're working on, or maybe you can give me some more insight on that. Because what Platypus is trying to develop is a gel-based pest control, if I'm correct. So how
Yes.
does it stand different from the regular alternatives that is out there in the market?
Okay, so Basically, let's say what's in the market today. So today in the market, there are several ways to make these kind of active ingredients
Hmm.
to spread in the field. This is what we need to do is, as a farmer, you need to spray it in the field or to make sure it interacts with the pest. It can do it with spraying. It could put it inside the irrigation water and in different and uh, in different ways in the field. But eventually, they don't want it to just you put it in the field, then it will evaporate.
Right.
You want to control it, so the farmer won't need to spray it all the time. So there are synthetic pesticides,
Mhm.
which chemically very efficient, and they interact with many organisms. They're
Mhm.
not selective at all,
Right.
and they'll survive in the environment for a long time. So you don't need good release way from the material to the environment because they'll stay in the environment as is for a long time. These
Mm.
are the synthetic materials, and they are very harmful, very
Right.
hazard to human and to plants, to microorganisms and pests. Very effective, but affecting other things as well,
Hmm.
environmentally. Um, then you have biopesticides,
Hmm.
which we're talking about active ingredients that are safer to the environment, and they are more selective. So you'll target only specific flies, for example, and not
Hmm.
all the organisms in your field. And then you need a better release mechanism from the material, from the product to the environment. So there are ways of using a gel with water. It's different from ours, but we can talk about it in a minute. And there are ways of, for example, um, using small spheres. It's called a microencapsulation. Small balls or spheres that holds the active ingredient inside, then makes it slow release to the environment.
Right.
There are several other ways. I don't want to go inside it to the chemistry,
Yeah.
um, but there are several other ways.
Hmm.
And eventually, what we are offering is a gel without the water that can control the evaporation of the active ingredients to the environment very slowly, much slower than what there is today in the market.
Okay. There.
If usually it takes between 2 weeks to 3 months of
Hmm.
the active of many active ingredients, with us, it can take up to a year. So that's the time difference.
Interesting.
Um,
Interesting. Gilad, I mean, firstly, thank you for giving an introduction to your own journey, the company that you're trying to build, and how Platypus, defines its product differently as compared to the other alternatives out there in the market. And I mean, but before we go to the next part of the conversation, which is looking at the problem statement itself, I think we have touched on the very superficial level of the pain points of the existing alternatives that is out there in the market. And you have given us a good understanding of what a pesticide is and what are the different components of the pesticide and how it acts and what are the different methods of delivery. So let's now get into the second part of the topic where we can dive deep into the problem statement. So let's look at the problem statement you're tackling today. Bringing a new synthetic crop protection product in the market is slow, expensive, and heavily regulated, as you rightly mentioned. Biopesticides, which you also highlighted, are faster but still face a significant hurdle in development, registration, and field performance. At the same time, farmers face environmental and regulatory pressure to move away from the harmful chemicals but natural alternatives often evaporate quickly and require frequent reapplication. And I believe this is genuinely the pain point that Platypus is trying to address. That is to have a longer diffusion time so that it stays on the ground for the longer period of time as compared to the different alternatives. But let me ask you this question. From your vantage point, Gilad, how would you describe the current status quo in pesticide control or pest control? Synthetic pesticides, biopesticides, or biological control? What is according to you, the status quo? What are the main pain points for growers and manufacturers?
So the pain points are different for each person in the chain. But from from the market point of view, synthetics still drive the primary revenue, and
Hmm.
but the growth has slowed. It's 3 to 5 CAGR. So it's still a lot of money, but
Mhm.
it's the income of today, not the income of tomorrow.
Right.
Because biologicals, the capital and the R&D are shifting to this sector and
Mhm.
are driving double-digit growth, about 14, 15%.
Okay.
These are huge numbers. So this is you can see how the industry react, that this is the future.
Mhm.
Do you see where they should go in the future? But they're still making money out of the synthetic pesticides that are more damaging to the environment.
Mhm.
Um, for the manufacturers, the pain points are, if we're looking at synthetics, the traditional R&D is basically unsustainable. It takes almost 12 years and $300 million to bring a single new
The new
active
product.
ingredient to the market. Just
Wow.
a new product. Think about the problem you have today. In 12 years and $300 million will reach the market the solution that is needed.
Mm.
It's too long. It's not sustainable. Now, if you're looking at biologicals, the development is much faster and cheaper.
Mhm.
And we're talking about up to 5 years in the longest cases, usually. Can reach even to 7, but usually it's between 3 to 5 years.
Mhm.
And the numbers are around less than $10 million. So it's
Far cheaper.
significantly faster. Yeah. But the problem is that they are unstable
Right.
in the environment, the active ingredients. So manufacturers need to find ways how to make the active ingredients stable at the environment in real world situation where you have heat, wind, sun, humidity,
Mhm.
um, and radiation. So, and for the grower, their
Mhm.
pain points are very different because farmer are losing in synthetics. They're losing effective chemical tools, and it's a big problem. Not always you have something uh, to replace it, a
Yeah.
biological that can actually replace the synthetic material.
Sure.
Um, and many times they can't really use some of the materials because they'll have residue inside the the produce.
Mhm.
And they're not allowed to sell crops when you have high dosage of residue of pesticides inside. And of
Sure.
course, there are a lot of regulation that bans these kind of materials. And also, there is a problem with the pest. The pests are becoming more and more resistant
To this active
to this.
substances.
Exactly. Now,
Right.
with biologicals, uh, the grower want safer options, and the problem is that existing pesticides often require a frequent reapplication.
Mm-hmm.
So driving up the labor and cost and fuel and basically makes it not very economical. So basically, synthetics face huge financial and regulation walls, while the natural options struggle with field durability. So
Mm-hmm.
we see this problem and saying in Platypus that we don't claim to solve every agriculture problem. We focus specifically on bridging that field stability gap so natural compounds can perform reliably in real field conditions.
Sure. I mean, you have given me so many aspects to think about, specifically within the world of pesticides. I mean, usually we don't try and engage on or contemplate on this problem statements that exist within the pest control, right? So, if I understand you correctly, there are three categories that I see. One is the synthetic pesticides, which are the traditional ones, where we see there is a slowing down when it comes to the Kega growth. 4 to 5% is what you mentioned. And then we have the biopesticides, which are now, kind of are seen are of the future because they are much more environmentally friendly as compared to the synthetic ones. And the problem that we see there is the increase in the labor and the way it has to be handled because of the fast release, and they're not
That's correct.
very effective presently there, right? But let me try and address the first category of that, which is the synthetic ones. And here you mentioned that usually to develop a product, it takes longer time, 12 years, and the cost of R&D is quite high. So my question to you, Gilad, is uh, those development timelines and costs for synthetic pesticides are enormous. Can you walk us through what or where that time and cost actually go? Is it in the R&D? Is it in the field trials, registration, data requirements? And why it is so hard to do in this in a more agile way?
So let's basically in the industry, people call it the RDR. We know R&D,
Hmm.
research development, and the extra R is for registration or regulation.
Mm.
Um, so that's the process for bringing this is the time to market or the process to develop a new synthetic pesticide.
Hmm.
The first part is the first R is research,
Hmm.
which means the discovery and screening phase of new active ingredient.
Hmm.
So the cost and time here is roughly $130 million and 4 years.
Okay.
And what happens is synthetic chemistry in high the basically doing a lot of screening and testing many active ingredients and active compounds and trying to identify them and test them. And we're talking about the scale is by research that I've done by Philip McDougall and Ag Bio investors for CropLife International.
Hmm.
Companies must screen roughly 150,000
Wow.
candidate molecules to bring just one single commercial product to market. These are huge numbers. So
Right.
at the end, they found this candidate. Now they need to move to progress
Right.
to the
Regulations to
second phase,
follow.
not yet development.
Okay.
So this is just the discovery part. Now we're at the development. So now they're trying to develop a formulation, how they are going to make a product out of it, how they are putting it, what's the other chemicals that they're putting inside, how they're going to apply it, doing field trials. These are another $120 million and
Mm.
another 4 years. So then they're optimizing the liquid solid formulations, scaling the manufacturing process. They're running several years of field trials in different locations globally and different climates and different soils types and crop systems, just to make sure it works and to see the effect on the environment. And then they are going to the last stage of the registration and regulation, which cost another $50 million and another about 4 years
Mm.
of testing. So now they need to conduct over 150 mandatory toxicological and environmental safety studies
Mhm.
to see that it doesn't damage groundwater and non-target organisms like bees. And they need to get the approval of the US
Regulatory bodies.
EPA or the EFSA or in every location. So it's a long process just to develop one product.
Right.
Um, and so why it can't be easily, to be more agile, biologicals,
Much more agile
the
that
na
way then.
yeah, nature moves at the pace of crop cycles. So
Mm.
you can't test a product any time of the year. You need to wait to the right time in the right season. And if you've missed that, you need to wait another year.
Mhm.
You can't just test it. It's not like an app you're putting at the app store and let's see how people download it and interact with it.
Sure.
Um, so
Sure. But I mean, just comparing it with the biopesticides, why is that that they can be formulated much faster? Are the
well,
regulations a little less stringent there?
yes, because if you're taking, for example, instead of a harmful material that
Mm-hmm.
can hit, can damage, let's say with rodents,
Mm-hmm.
mice and moles and stuff like that. Let's say you want to use a um, synthetic material. It can damage the rodent that you want to kill.
Mm-hmm.
It will do the job, but it will also, if your dog would eat it,
It can kill that
it
as
could
well.
damage it can kill the dog. If a kid will eat it, it is a very hard risk. And the alternative, for example, is use mint oil.
Mm.
Now, we as human, we eat mint. We know we can absorb it. We know it's not very dangerous for us, and not for dogs, and not for other animals. But it still repel. It won't kill. It repel mice.
Sure.
So they don't want to come to your house, but you have something that is safe for you and everyone in your house.
Right.
It's a trade-off. It might be not as effective as,
The synthetic
but
ones.
it's safer. So the regulation body, they see that, they say, okay, it comes from a natural source. We know there is a lot of research that it is safe. It
Mm-hmm.
is more selective, and it will degrade in the environment faster than the synthetic ones. Let's do a fast track for these kind of materials
Sure.
because we know they are safe and the damage, that the potential damage is lower.
Right, but Gilad, there is a problem again with the bio alternatives, which is natural is better but less reliable from a materials and chemistry perspective. What are the specific limitations of, let's say, essential oils or pheromones or other volatile biocompounds in this field? Because that's one a pain point that you also brought up in one of your previous answers. But can you throw some more light onto that?
Okay, so first let's enter a new term.
Mm-hmm.
It's called IPM, Integrated
IPM.
Pest Ma yes, Integrated
Mm-hmm.
Pest Management.
Mm-hmm.
Um, it's not one solution fits all. It's let's try to have a system of different approaches and different solutions depending on how severe the problem of the pest is. Because if I have a field and I have only one fly,
Mm-hmm.
that's I don't need to spray the whole field. So let's just put traps.
Right.
If I have a field and I have a lot, okay, maybe we should use synthetics because otherwise it could go to everyone around all the other fields around. So the idea is let's find the problem and solve it the same size as the problem is, and not use
Right.
just the same solution all the time. So
Mm-hmm.
that's where many growers, and this is the first, let's say the first way of thinking that many farmers and
Mm-hmm.
and professionals are going to this direction in the recent years. So they're using essential oils and pheromones and the other volatile compounds because they are more selective and and they have a specific effect on each pest. For example, you can use essential oil to repel pest A, but you can use another different essential oils to lure to your field insect that will eat your pest A.
Right.
So you have different ways to think about it and how to deal with the problem.
Mm-hmm.
And you can also put traps with a pheromone. A pheromone is a compound that attracts and lure or confuses the pest.
Mm-hmm.
So you can trap them, and then the effect would be much lower
Right.
on your field. Um, so the main the limitations here are, as we said earlier, it's high volatility because
They evaporate
compounds,
faster.
yes, they evaporate to the environment faster, and in the field, they evaporate in hours or days,
Mm-hmm.
and you and it's hard to make them to last and evaporate for over a long time.
Right.
Now, there is also hard conditions because there is a process called photodegradation. It's when UV radiation or solar radiation breaks down the organic bonds of these compounds. So they're just breaking down and they're not effective.
Right.
Uh,
Right.
and the temperatures and the humidity are also affecting their how they operate in the field.
Sure.
Uh,
Sure.
so these
So
kind,
Gilad,
yeah,
I mean, if I understand you correctly again here, there is no one solution that fits all. Maybe that was an approach that we had taken with the synthetic pesticide that you spray the entire thing, but maybe you are overdoing it or underdoing it. But that is not a most safest or an effective way of handling pests. So the second version is a bio option, but it is not reliable given that it might not solve the problem. So what the term that you introduced is IPM, integrated pest management. Depending on the level of the problem that you have, you come up with a solution that fits that problem, and you not over design or overdo the thing. Is a correct understanding of mine?
yes, it's a different way of thinking. You're not it's like when you have a headache, you not necessarily have to take a pill for headache. You
Right.
might be just a little bit dehydrated, so drink a little water. It might fix the
Mm.
problem.
Sure.
Uh, let's not just go to the doctor for every small thing. That's the idea.
Correct. Right. Right.
Um,
Right. So Gilad, I mean, it was very fascinating learning your world, and also thank you for again for helping me understand the problem statement in its depth, because this is a real problem, and the impacts of excessive use of pest is now being felt everywhere, from various problems related to human health. It could be cancer, it could be other issues, and also the pests themselves building a resistance to the synthetic chemicals today, which is making it a much more problematic. And maybe this problem will, I mean, increasing the dose simply will not solve the problem. I think that's one way to look at it, right? So Gilad, we will now switch to the next subtopic, which is looking at the solution aspect of things. So we'll look at the Platypus solution. So you're not a pesticide company, you are a materials platform company. PlatyForm is a gel-like biodegradable delivery material that slowly releases volatile natural compounds, extending its effectiveness from weeks or a few months up to potentially a full season, depending on the formulation. You sell this as a raw material to manufacturers, enabling them to build multiple products on a single platform. So I believe for our listeners now, it is making much more sense when you said what is the platform that you're referring to. So let me ask you this first question under this segment. So for a non-chemist listening, walk us through how Platyform works. What is this material, and how does slow and controlled release of volatile bioactives actually look like at the microscopic and field levels?
okay, so basically, the platform is a gel. Think
Mhm.
about it as something like peanut butter.
Mm.
Um, can be more solid, can be more liquid, but let's think about it as a peanut butter. And the idea is that it is made of natural substances that they are all biodegradable and safe for the environment.
Mhm.
And if you accidentally eat it, so you won't die, most likely.
Mhm.
Yeah, but the idea is that if the farmer touches it, so he knows it's not going to, he doesn't need to seek to go to the emergency room.
Mhm.
He can wash his hands and it'll be safe. And the idea is that you inside, this is the platform. Now add inside a compound, let's say mint oil that we mentioned earlier. This compound is want to evaporate very fast.
Right.
Um, it's produced from mint
Mhm.
and it's oil, so it can mix very easily inside the platform, and then it stays there. When you open the container it holds, so it starts to evaporate to the environment.
Mhm.
You'll smell a lot of mint oil. Now, because the gel is very thick and it creates an environment, a chemical environment inside the gel that the mint oil still want to stay inside, it
Mhm.
will stay inside. But it slowly move to the surface and evaporate from there to the environment. So it will be like a candle that's still, you know, from one very
Slowly.
small point, slowly evaporating or slowly breaking down. So here it won't break down, but it just evaporate.
Mhm.
Eventually, what it creates some kind of a cloud in the area. And when a pest come nearby, you smell it. Now it depends what you feel with the smell.
Mhm.
Sometimes they smell it and they say, I don't want to be here. I'll go to the next field where they don't have this smell.
Mhm.
or I like the smell, I want to come here. Depends what you want to achieve. Usually, if they like the smell, you'll put it inside a trap. So they'll go inside the trap and stay there.
Right.
And then they'll reduce the population and they'll have the next generation would be smaller and smaller. That's the idea. Or they won't be in your field. So this is the interaction we're looking at, and it can be inside some kind of a vessel,
Hmm.
inside a tube, inside a sachet, or different kind of containers that you put it inside the field or the greenhouse or the storage of food. That's the idea.
Right, right. I mean, again, it's definitely solving for that problem of reliability of this biopesticides, right? Which increases the reliability aspects, meaning it'll last longer. But I mean, I'm just trying to understand the chemistry behind this. So, what is that is making this gel or platiform stay longer and allow for a slow release of this materials to the atmosphere? Is it, I mean, is it something that you're using that is unique, that makes this gel? I mean, I do not want you to give me the formulation so that the world can copy it, but can you maybe throw some light into how does this gel stand different from the other options that is available in the market?
Yeah. So um, basically, what what's so unique about our gel is first, it is water free.
Mm.
It doesn't contain water. Secondly, it is it has a unique mechanism we've developed, a chemical mechanism that control the evaporation and the active ingredients. They don't want to leave the gel very fast.
Right.
It's like speed bumps that we're putting inside our gel and tell the gel, the volatile molecules, you can pass, but you need to move slower here.
Mm. Slow
That's the
down.
idea. Yeah, slow down. So this makes an effect of the slow release or controlled release,
Hmm.
and extending the use time for a very, very long time. Instead of using it for usually to a few weeks, up to 2, 3 months, we show how we can control it for a very long time.
Right. Can you give me
Uh,
an example, Gilad? Let's say if it's an property which is an acre of, let's say, some field, right? And if this sort of chemical is going to be used, what quantity do you have like a math to it, like 1 square feet area? This is a kind of quantity that might be required. What's the mathematics like? If a farmer were to come to you and ask for a solution, I mean, what is the simple math that you could talk to him or
so
her?
it really depends on each pest, crop, environment, and many and what's already in the market.
Mm.
You don't want to do big changes in the market. If a farmer know how to work in one way, but tell him instead of blue, use white, that's great. He can do that. I don't want to do big changes.
Right.
Don't tell him instead of 5 blue, put 15 reds. That's too
Mm.
much.
Hmm.
Um, but for example, I'll give you an example from a field trial we had. We used a compound called methyl eugenol.
Hmm.
It's a natural compound. It attracts flies, the peach tree fly, into a
Peach
trap.
tree. Hmm.
Yeah, other flies as well, but let's focus on this specific trial.
Hmm.
And we put it in the field and compared it to a commercial dispenser, the same active ingredient they use. We put the same amount, but in different percentage. So we put they use let's say 30% of active ingredient.
Mm-hmm.
We put 20% and 10%. We tested the two versions, and we put it inside traps and in the orchard.
Mm-hmm.
And the commercial material claims to work for 90 days. We came back after 200 days to the traps and sent the samples to a lab to test how much this compound, this methyl eugenol, left inside the materials.
Right.
They started at 30%, the commercial dropped to 5%.
Mm.
We started at 20%, dropped to 10. The 10% we started dropped to 5
In
in
a span of
200
200
days.
days. Mm.
200 days in the Israeli summer.
Right, right.
So it's so high temperatures. And from the biological point of view, we looked at the formulations and we saw similar results.
The effectiveness is same.
Yeah, the effects were the same. Both the active ingredient was working the same on the pest.
Mm.
So, but what we showed is that we can use less active ingredients and control their evaporation for a longer time. We had
Mm-hmm.
another year or another season that it could stay inside. So here the effect is huge for the farmer
Mm-hmm.
because they don't need to reapply.
Right.
Now we tested it compared to the most advanced commercial material. Many other of the competitions in this specific dispenser, they are claiming for 40 days, not 90
Mm.
days. So if they can one day achieve instead of 40 days,
200 days.
200 days, that's that is a big
Money
change for the
saved.
market and a lot of money saved. And the one that is going to benefit the most out of it is the farmer.
Sure. Sure, sure, sure. I mean, yeah, that's the more effective the product is, it's much more comfortable on the farmer's pocket. That's definitely there. Let me try to put myself in the shoes of a manufacturer who's a manufacturer of the compound. Where is his money being saved? I mean, what is the value addition that I get if I were to work with you?
Sorry, can you repeat the question?
So if I mean from a farmer's perspective, it is
Yes.
money saved because longer time you do not have to change the pest control that you have implemented on your fields. That's as clearly a saving for them. But if I were a manufacturer who is a manufacturer of an active compound, for me, my money comes from higher sales, right? So if I were to put myself in their shoes and choose to work with PlatyForm today, how can I, add value or how can my value addition increase in this entire? I mean, I'm talking from the economic side of things.
Yeah. So there are several perspectives that we can look at it. First, the incentives are different for each
Mm,
company. That's correct. You want to sell more, so you don't want a highly effective um, um, product. But if your product is not selling good because you're the worst product in the market, you look for a better technology to lead the market. So
right.
once you lead the market, the other competitors will have to catch up.
Sure.
Okay. So, and once you have better unique selling points, when you're coming to a farmer and saying, hey, with me, you need to put once a year and not 5 times a year. So yeah, you'll sell less, but
Maybe charge a
you
premium.
could you first you could charge premium, then you can expand it, and it will be easier for you to sell more to new customers. not only
Sure.
to your current customers.
Yeah.
So that's something that you need to think about in the distribution line.
Mm.
That at the store, when the farmer goes and see the salesperson there, he'll tell him, yeah, this cost $5, but you need to reapply it 5 times a year.
Right.
But you can use this one and it will cost you double or triple, but you'll need to apply it once or twice.
Sure. That's a valuation. Great. So, Gila, let me try and summarize what we have discussed so far since we are coming towards the end of the entire conversation. So, we looked at your journey, of course, how Platypus came to be, and the kind of work that you're trying to achieve through Platypus. We looked at the problem statement, of course, the problems with the synthetic pesticides, the health hazard it has, the resistance that we have seen building with the pests, which is adding to the significant problem. There is also the economics angle that we looked at, the cost of producing one formulation when it comes to synthetic material, taking 2 years of time, 300 plus millions spent in R&D, the time it takes to reach the market with all the RD and the 2 hours to follow, the regulations as well. And alternative of the future is, of course, the biopesticides, which are safer for human health. But again, we looked at the problem that exists there, which is the reliability factor, because it being more volatile compounds, it evaporates faster. So as a part of it, we have looked at the solution that PlatyForm has today built, which is a gel which slows down the entire process, staying as effective it is supposed to be for an effective pest control, right? Increasing the timeline from a 90-day to a 200-day timeline, right? So very clearly, I see that this is a genuine problem of pesticide. There is a solution which is switching to more safer bio pest control, but making it more effective requires a better uh, you know compounds or substances which allows for a more effective and an efficient way of having them tested. Right. So Gilad, let's move to the last topic. I know I'm overboard because we have already reached the 2 hour timeline. You're okay with 10 more minutes? Sure.
Yes.
All right. So let's move to the last topic, which is India 2047, building a low toxin food system via India-Israel AgTech collaboration. So, the centenary of independence, which is India 2047, the 100th year of independence, a key milestone for our Sustainable Bharat vision, Gilad. India is seeing a rapid growth in biocontrol, IPM approaches, the essential oil-based solutions across horticulture, plantations, and protected cultivation. At the same time, the country faces intense pressure to decarbonize food systems, reduce chemical loads, and meet both domestic and export market standards. There have been multiple example in the recent past where many of the Indian exports like mangoes and tea products have been rejected and sent back. Reason being excessive use of pesticides there. I mean, the regulatory bodies have sent it back, right? So these are real challenges. So my first question here is from your vantage point, Gilad, in Israel's agri-tech ecosystem, how do you see India today as a market, as a partner, and as a laboratory for sustainable pest control solutions and ecological materials?
Well, um, first of all, the connection between Israel and India are it's amazing connection, and it lasts for many years in different aspects, not only in agriculture.
Right.
And the from the reality of the Israeli ecosystem of the agtech ecosystem is highly innovative and active, and it making it a great proving ground or playground, if you want to call it, to develop the test and test new technologies. But Israel is geographically very small. It is not a large enough end market on its own for Israeli agri-tech companies to grow. International collaboration is basically essential. And
Right.
India is the ideal partner and market because it has strongest institutional framework. India and
Hmm.
Israel have established ongoing bilateral programs specifically designed for to bridge their agricultural sectors.
Right.
There are many centers of Indo-Israel excellence in India, and combining the strength, the partnership pairs Israeli technology and innovation with India, very strong specific expertise, and the large-scale manufacturing capabilities, uh, and the massive agriculture footprints. That's huge advantage. And so India offers enormous market scale and potential for both nations.
Hmm.
And there is a clear openness among Indian farmers and the broader market to adapt biopesticides and
Right.
transition towards more sustainable pest control solutions because essential oils, for example, are in the highest usage globally in India.
Interesting.
India leading the world with essential oils, where other countries just see it as they are very
Right.
skeptical about it.
Right.
So
I
that's
mean, of course, the history that India and Israel has is quite time tested. That stays. But in the agro sector as well, as you rightly mentioned, there are definitely areas where we could collaborate, we could work alongside, and a huge population of India is still based on farming, and the it's a livelihood for many people. And given that the problem today that we face with pesticides has become a real challenge, and if we were to produce products that are meant for the world, which meets the global standards, which can meet the importers' requirement, that demands to have more effective pest control in the most effective way as possible. And there I clearly see an overlap. But let me ask you this, Gila, given the India scale and diversity, where do you think this slow release natural solutions like PlatyForm make the most sense as early pilots? Is it in the fruit and vegetable value chains? Is it in the spices, plantation, storage, logistics, or elsewhere? Where do you see the pilots?
uh, um, I think focusing on high value export crops
Mhm.
is the highest value. From the crops perspective, the like fruits, vegetables, spices benefit the most. These
Mhm.
growers face strict residue limits and they have a strong financial incentive to protect their yields.
Sure.
And I think it should start with monitoring and trapping, and um, because it will be the most effective entry point,
Mhm.
using these kind of slow release platforms, first for pest monitoring in fields or greenhouses. Um, and reliable release gives farmer accurate monitoring data. So they know
Sure.
exactly when and how to respond, avoiding unnecessary spray application, which
Mhm.
prevent these kind of residue and won't ban their shipments.
Right.
Um,
Gilad, just sort of curiosity, has a trial been undertaken here in India yet from Platypus?
uh, we have one collaboration with a company using essential oil, more focused on home and garden, less
Okay.
agriculture, but still very interesting project.
Sure, because gardening is also something that is picking up. I mean, I'm not saying it is picking up right now, but maybe given that people have found I mean, as the per capita income grows, you find new hobbies. And the new hobbies, I think gardening is one among them. So that's definitely a sector that is growing here in India because
But they are
even
part of an international organization, so it's we're looking globally with this kind of products.
right.
Um, yeah.
Very interesting, very interesting. So let me ask you one last question. I mean, just to try and get your thoughts on the 2047 vision there. So, if you had to design a 10-year roadmap for India to reduce its reliance on harmful pesticides while keeping yields and farmer income stable, what pillars would you include? Would it be materials innovation? Would it be IPM adoption? Or is it policies, incentives, data? What according to you?
Well, I'm not an expert on how India should do things. But if you're asking me, I'll say that it should be a combination of top-down and bottom-up approach,
Right.
because real transformation can be pushed from just one direction. It requires a comprehensive regional or state plan that aligns top-down policy with bottom-up farmer engagement for a long-term horizon. I mean, for example, policy and regulatory should be combined as a top-down policy. Government and frameworks must actively back and fast-track safer biopesticides and biologicals for farmers. And the policy should establish clear guidelines and uh, the registration processes to make it more effective for
Effective, yeah.
companies. And from the other side, direct financial and operational incentives. If providing targeted incentives to both ends of the supply chain and for the companies and the farmers and even the consumers to go to more organic growing
Alternates, yeah.
and reallocate the subsidies towards sustainable crop protection instead of using synthetics ones.
Sure.
And another side is education and honest communication, not to try to brainwash people, just to
Hmm.
focus on transparent, practical education through networks and field demonstrations rather than high-level marketing. Um, Clearly showing to the growers the benefit of the long term, of the healthier soil, and how to improve the quality of the crop. And then they can sell it in higher price and market value and sustainable yields. So they choose to go to this direction and they choose to go to this direction and not just go there because someone told them to. So
Right,
that's how I see it.
right. Um, Thank you again, Gilad, for sharing your thoughts. I think for listeners, they would definitely find value in what you have shared today, and also to give your perspective from your lens. The value benefits for both policymakers, manufacturers, and also farmers. I think that's as crucial because the the 10-year roadmap that you've provided is more holistic in nature, not just a siloed thought-wise. So thank you for that. So great. I think we have come towards the end of the podcast. Thank you very much
Thank you.
for
Thank you.
so Gilad, thank you for this deep dive from your journey on factory floors to ecological chemistry through the hard economics of pesticide and biocontrol innovation and into a vision for seasonal, slow release natural pest control that could help reshape food systems. For our listeners, a few core traits that stand out. The first one is the innovation bottleneck in pest control, years and hundreds of millions spent on a single synthetic molecule. creates both risk and opportunity for materials driven solution. The second is the Platyform solution, the Platypus solution, which is PlatyForm, show that if we treat volatility and evaporation as a design problem, we can make natural solutions last longer, reduce repeated applications, and change the underlying business model for manufacturers and growers. In markets like India, where IPM and ESG-linked food supply chains are gaining prominence, international collaborations around ecological materials could become a powerful lever for building a low-toxin, climate-aligned food system by 2047. For those who want to learn more about Gilad's work and Platypus technology, you can visit Platypus website. We will put it in the description and also the link to Gilad's LinkedIn profile. If you're a business leader, sustainability head, or agro-food decision maker thinking about ESG strategy, carbon accounting, and integrating innovations like ecological pest control into your broader climate roadmap, our team at Carbon Mandal would be happy to partner with you. Visit www.carbonbundle.com to explore how we can. This has been the Carbon Circle with me, Roshan Rai, in conversation with Gilad from Platypus. Thank you for listening. And until next time, let's keep building a sustainable Bharat by 2047, one honest and meaningful conversation at a time. Thank you so much.